Scientists, astronomers, and space agencies from all over the world are working tirelessly to keep an eye on the night sky for any objects that could pose a threat to Earth's safety or well-being. The Taurid meteor stream, which poses a continuous and tangible threat to humanity's existence and the integrity of our planet, is one of the most significant collision risks identified by the scientific community among the myriad of potential hazards lurking in the vast expanse of space. Advanced technologies, international collaboration, and the combined expertise of astronomers, physicists, and space scientists are all required for the multifaceted task of detecting, tracking, and analyzing celestial objects that could potentially intersect Earth's orbit. Our capacity to identify and evaluate potential threats from space has significantly improved in recent years as a result of advancements in space observation technologies and the establishment of global networks devoted to asteroid detection and monitoring. These efforts emphasize how crucial it is to make investments in space exploration and robust planetary defense strategies to protect our planet from cosmic risks that are always present. Both the scientific community and the general public have always been captivated by the discovery and subsequent investigation of space objects, because they provide glimpses into the mysteries of the universe and prompt profound inquiries regarding the nature of our cosmic surroundings. Unique objects, like the mysterious interstellar visitor known as Oumuamua, frequently pique scientific curiosity and spark intense speculation. As the first object ever observed entering our solar system from interstellar space, Oumuamua's historic discovery provided an unprecedented opportunity to investigate a visitor from beyond our cosmic neighborhood. Scientists were faced with the challenge of deciphering Oumuamua's origin, nature, and trajectory after initial observations revealed a variety of peculiar characteristics that defied standard classification. Its peculiar trajectory and velocity, as well as its initially described cigar-like shape, which was later identified as pancake-shaped, raised intriguing questions regarding its composition, structure, and possible extraterrestrial origins. The absence of a coma or tail, which is typically associated with comets, further fueled speculation regarding its true nature, eliciting a variety of hypotheses from members of the scientific community and captivating the public's imagination with visions of possible alien spacecraft. The subsequent deployment of cutting-edge instruments, like the James Webb Space Telescope, provided unprecedented capabilities for in-depth interstellar object observation and analysis, marking a significant turning point in the investigation of Oumuamua and other celestial phenomena. The James Webb Telescope, with its cutting-edge infrared cameras and cutting-edge spectroscopic instruments, revolutionized our understanding of interstellar visitors and their implications for the wider field of space science. It provided scientists with unparalleled insights into Oumuamua's characteristics, composition, and behavior. Scientists were able to confirm that Oumuamua was not an artificial structure or extraterrestrial spacecraft, but rather a natural object made of rock and metal through careful observation, data analysis, and collaborative research efforts. By providing detailed insights and persuasive evidence for Oumuamua's natural formation and interstellar journey, the James Webb Telescope's meticulous observations helped to dispel some of the initial speculation and uncertainty regarding its origins. However, despite these clarifications, scientists around the world continue to be captivated and intrigued by Oumuamua's peculiar features, such as its elongated shape, rapid rotation, and unusual characteristics. The object's unique properties and evolutionary history were the subject of further in-depth research as a result of this ongoing fascination. This led scientists to investigate the underlying mechanisms that shaped Oumuamua's passage through our solar system. The abundance of information gathered during Oumuamua's brief journey through our cosmic neighborhood provided a unique opportunity for scientific investigation. Researchers were able to examine these interstellar visitors up close for the first time thanks to their close encounter, which provided valuable insights into the intricate processes that govern their formation, evolution, and dynamics in our cosmic environment. Scientists gained a deeper understanding of the fundamental principles that shape the behavior and trajectories of interstellar objects traversing the depths of space by meticulously analyzing the data collected during this remarkable event. In point of fact, the in-depth investigation of Oumuamua's trajectory, characteristics, and interactions within our solar system produced priceless scientific data that shed light on the intricate interaction of cosmic forces. In addition to enhancing our appreciation of the vast and diverse universe we live in, This deeper comprehension stands as evidence of the remarkable advancements in observational astronomy and space exploration. The legacy of Oumuamua's visit will continue to inspire future generations of scientists and explorers to unravel the mysteries of the cosmos and expand our collective understanding of the universe we call home as humanity continues to push the boundaries of scientific inquiry and technological innovation. Scientists were able to analyze the size, shape, surface features, and spectral properties of Oumuamua during its flyby, which shed new light on the variety and complexity of interstellar objects traversing the vast expanse of space. Astronomers and scientists began a comprehensive analysis of the data gathered during Oumuamua's brief visit as it moved away from our solar system in an effort to decipher the remaining mysteries surrounding this mysterious interstellar traveler. Through ongoing research and scientific inquiries, Oumuamua's historic encounter with our solar system continues to shape our understanding of the cosmos and our place within it. In conclusion, the investigation into Oumuamua serves as an illustration of the significance of cutting-edge space telescopes, like the James Webb Telescope, in deciphering the mysteries of the universe and broadening human knowledge. These groundbreaking instruments enable scientists to explore faraway lands, decipher cosmic mysteries, and gain a deeper understanding of the nature of celestial objects and their implications for universe life by pushing the boundaries of observation, data analysis, and scientific inquiry. The scientific knowledge and discoveries made possible by Oumuamua's visit live on, paving the way for future explorations of our cosmic surroundings and the opportunities and challenges they present for humanity's ongoing quest to explore the cosmos. Yes, let's investigate the subject in greater detail. The Taurid meteor stream, also known as the Taurid meteor stream, is a fascinating and intricate cosmic phenomenon that has piqued the interest of astronomers, astrophysicists, and scientists from all over the world. The possibility of debris from 55P/Temple Tuttle, a regular visitor to our solar system who completes an orbit around the Sun every 3.3 years, posing a threat to Earth, is its significance. Due to the fact that its radiant point appears to originate from this specific region of the sky, this celestial spectacle has been given the name Taurus. Not only does the Taurid meteor stream dance with Earth's orbit, but also the size and composition of the debris it holds within its cosmic embrace make it particularly alarming in terms of potential cosmic impacts. Astronomers and scientists from all over the world have paid close attention to the Taurid meteor stream, an enigmatic celestial phenomenon of profound complexity and mystery. It is made up of a captivating combination of cosmic elements. The finest dust to compacted small rocks and occasionally larger meteoroids of varying sizes and compositions make up the intricate web of cosmic materials that make up this cosmic tapestry. From tiny particles measuring just a few millimeters to more substantial meteoroids with diameters of several centimeters. This diverse collection of celestial matter creates a rich mosaic that spans a wide range of dimensions. Inside this enormous exhibit lies a gold mine of understanding into the key cycles forming our planetary group's development and the more extensive elements of the universe overall. The cosmic symphony of creation and destruction that has taken place over eons is represented by each component of the Taurid meteor stream, which functions as an artifact of the cosmos. Astronomers and other scientists are shedding light on the celestial forces that control the fabric of our universe and our place within it, as they delve deeper into the mysteries of this celestial tapestry and unravel the intricate threads of cosmic evolution. Even though the individual components of this cosmic conglomeration may appear harmless on their own, their combined presence poses a significant threat if they come into contact with the atmosphere of Earth. There are periodic encounters between Earth and the debris field because the Taurid meteor stream's path intersects with Earth's orbit. Meteor activity is heightened during these celestial rendezvous events, which also raise the likelihood of spectacular meteor shower events that captivate both novice and experienced astronomers. However, there is the potential for more than just stunning visual splendor within this celestial spectacle. Although many of the meteoroids in the Taurid stream are small and explode when they enter the atmosphere, larger objects have the potential to survive the journey and land as meteorites on Earth. In point of fact, the possibility of larger meteoroids from the Taurid meteor stream striking Earth's surface has sparked significant concern in both the scientific community and space agencies. Larger objects, on the other hand, have the potential to cause significant harm if they come into contact with the surface of our planet, in contrast to their smaller counterparts. which simply disintegrate when they come into contact with the atmosphere of Earth. This concern is not just theoretical. Rather, it is based on geological evidence and historical precedent that attest to Earth's past encounters with major impact events, each of which left an indelible mark on the history of the planet and its ecosystems. Astronomers, space agencies, and researchers have developed a wide range of strategies and technologies to protect our planet and its inhabitants from the possibility of cosmic impacts. The early detection and tracking of near-Earth objects, NEOs, including Taurid meteors, is the most important of these measures.